So let's get started. This is Bob Kuckler. We're here online today with sort of two different channels to view the session. We have the Google Hangout session going on, and at the same time we have a YouTube live session, and they're both on different mechanisms, if you will. I'm just going to introduce Derek Konofalski. And Derek, let me know if I pronounce that wrong, but
it's close enough.
Derek is a multimedia analyst at the city of Gilbert, and he's been running the city of Gilbert's Spark App League coding event program for what, 2 or 3, 4 years now, Derek?
I've been involved with the program for 3 years. I've been running it for 2 years now.
Okay. Anyway, Derek's also a software developer. He helps a web development firm in the Phoenix area when he's not working for the city of Gilbert. I've seen his work with Spark App League, and it's fantastic. So we've asked Derek to help us with training all of us to be mentors for Dev Day Yuma, and I think it's going to go well. So Derek, I'll just turn it over to you.
Awesome. Thanks, Bob. So hi, everyone. I'm Derek. I'll be doing the training today. I'm just going to start, kind of dive right in by giving a general overview of what we're going to talk about today. And then I'll do the same thing, kind of the same format each week as we go through the different parts of the training. But today we're just going to start with a really broad overview of the tools that we're going to be using. So in this case, Scratch. And then I'll start working on a simple project. This won't be the project that we take through to the end of the 4 weeks, but it will be kind of a starter project that I'll leave with you guys. If you can follow along while we're working on this, then great. I'll walk you through setting up an actual account with Scratch if you don't already have one. It's pretty easy. We won't take too much time on that. And then at the end, there will be just a little bit of homework. I say homework. It's really more of just a place where I'm going to leave you to kind of explore Scratch and make your own changes to the project that we do today. And that way, when we come back for the training next week tomorrow, you'll already have kind of the foundation for what you need to build off of that. So if anybody has any questions, Bob, if you can unmute everybody.
Okay.
All I ask is if you individually can mute yourselves, then that way you can unmute yourselves whenever you have a question. If we mute you, then you can't unmute yourselves. So if Bob can unmute everybody, then just go ahead and quickly mute yourselves so that there's not a bunch of crosstalk and noise going on. But if you have any questions, feel free to just unmute yourself and go ahead and ask. And we'll go from there. All right, so I'm going to share my screen. I'm going to jump right into the Scratch window. And how many of you guys have used Scratch before? Everybody's new? Okay, so have you all created Scratch accounts, and are you able to go to the Scratch website and kind of see a similar screen to what I'm seeing?
Yes, I can. 2
yeses. Fernando, can you see that as well?
Yes.
Okay, perfect. And Fernando, can you mute yourself?
Hold on. Let me check.
Just if you move the mouse around, there should be some buttons up near the top of the Hangout screen where you can mute yourself.
Yeah. Got it.
Awesome. Thank you. Okay, so jumping into Scratch. So when you first get to the website, it's just scratch.mit.edu. All you need to do is jump into this create link right here. I've signed in to my Scratch account. So in the upper right-hand corner, if you're not signed into a Scratch account, you should be able to click the link that says sign in. On the sign in link, there's also an option to create a new account if you haven't created one already. But go ahead and do that if you haven't. If you have, go ahead and sign into your account and then just click this create link right here. And that'll take you to a brand new Scratch window to make a new project, essentially. So when you create a new project, what you'll see is the main Scratch window split up into 3 different panels. So the first one is this upper left-hand section here, which is kind of, I would say, the most important window in the Scratch interface, because this is what the actual final project looks like. This is called the stage. And the stage is what people will see when they open your Scratch project. They're not going to see all these windows on the left-hand side. They're essentially going to see something like this. And so they don't get to see the back end. They don't get to see your little characters. They just get to see this window. So that's really the most important window. Now, from a mentor perspective, this window on the right is probably, or this section on the right is going to be the most important section, because this is where all the actual coding happens. And some people might take issue with us calling this coding, because we're not actually writing any code. We're just using these little blocks in the middle section here. But what we're essentially doing is coding. We're writing recipes to make the computer, or to make Scratch do what we tell it to do. Even though we're not typing it out, we're still writing instructions for the computer. So in its most basic sense, that is code. We're doing logic. We're using variables and different contexts and controls to tell the computer to do what we're asking it to do. So this is probably the second most important piece in the Scratch window. It's split up into a main panel with a couple tabs, and then, excuse me, second. So you, which is work happens, and then you have sounds as well. And we'll touch on each of these 3 things in a couple of the later sessions. For now, we're only worried about the scripts window, or the scripts tab, and the code window here on the right. Okay, and then the last section is the sprite section, or the kind of the visual section, or the graphical section of Scratch. So this is where we see all the different items, or all the different objects that we have in our Scratch stage. So most of the time we're going to refer to these as sprites, and all sprites are really characters or objects that we're going to interact with in our game or in our project. You don't necessarily have to create games in Scratch. We're going to make a game just because I think that's the easiest way to get through some of these code blocks. But it can be any kind of object. It can be a button that you click on. It can be an icon that somebody uses. Or if we wanted to make a paint program, then it would be like the brush that you use to paint stuff. Those all show up as sprites or objects. And again, a sprite is just kind of a game design or project design parlance that they use to refer to an object that you can interact with. So we've got our stage here, our code window on the right, and then our sprites or graphics on the bottom left. Does anybody have any questions on those so far? Just give me a head nod, thumbs up. Perfect. Okay. So what we're going to do is we're going to start off with making a very, very simple project just to
Can I ask a question?
Yeah, go for it.
Yeah, I didn't have my Scratch page open when you were going through it. Can you just quickly go to the 2 links that you were talking about, the stage and...
Yeah, so this area up in the top with Scratch the cat, our little character, is the stage. And this is essentially the most important part, because this is what the actual project will look like. So this icon here, to make it full screen, that's where you actually see kind of the final product. The code window is on the right here. We've got some blocks here that we'll go over in just a few minutes. But this is where you're actually going to create your project. And then down here in the corner are the sprites or the graphics.
All right.
Okay.
Okay.
All right. So first things first, we're going to talk about how these code blocks actually work. So up at the top here, you'll see a couple different categories of code blocks. We're just going to start with the default one, which is motion. And what happens in the motion panel and with these code blocks is these are literally the instructions that you're going to use to tell Scratch what to do. The way that I like to look at it is like any kind of coding or programming. It's really just a recipe that you're telling the computer to do, just like you're cooking food or following the instructions, you know, on the label for some kind of food product. It's literally the instructions in the order that you tell them to be done. And if you branch out or tell the computer to do multiple things at the same time, it will do those things at the same time in the order that you specified. And especially with Scratch or some programming languages, it's really, really important that you understand that the computer's not going to do anything unless you've told it what to do. And it doesn't branch off. It doesn't do any kind of special stuff. It only does exactly what you tell it to do. And the reason that I'm stressing that is because as you're working on things, you'll find that obviously not every program is going to work correctly. You might find bugs, or it might do something that you didn't intend it to do. And a lot of the times people want to look at, you know, restarting Scratch, or they think that it's an issue with the website because, you know, they wrote the code exactly and it should do what they think it does. And then when you go through it step by step, you actually realize that, oh, it's doing something that I didn't intend it to do, and it's doing it correctly. The code is wrong. It's nothing to do with Scratch. It's nothing to do with the interface. It's just that the code you've written might not function the way that you initially thought it would. So what we'll do as we go through the project is we're going to go through our code line by line several times, and I'll intentionally put in some mistakes just so that you can see some of the stuff that I'm referring to. So as we start, Scratch the cat is our first sprite or our first object. And so any of these blocks, if I click on them or double click on them, you'll see that it does exactly what that block says. So if I double click on move 10 steps and turn 15 degrees and point in a direction, you'll notice that my stage updates exactly that way. Okay. One thing to kind of pay attention to is that Scratch does use a regular XY axis grid, just like you would find in any kind of math or geometry. So negative numbers are left. So as I double click on negative 10 steps, it moves my character to the left. Positive numbers move to the right. And when we get into Y values, positive values for Y will go up and negative values for Y will go down. It's really easy to see this. If you look at the bottom here, bottom right of the stage, it actually tells you the X and Y coordinates of where your mouse cursor is. So you'll notice that as I move to the top, the Y values go up. And you'll also notice that there's a maximum and a minimum value. It's 180 up at the top and negative 180 down at the bottom. On the left, it's negative 240, and on the right is 240. Okay, so those are kind of the coordinates of every single object in Scratch. So right now, Scratch the cat, if you look in my blocks over here, as I move Scratch the cat around, or even I can drag him around with the mouse, what you'll notice that happens is that a lot of these blocks, the coordinates update. So if I move Scratch to, or try to get him at 0, 0. So if I move him to 0, 0, wasn't close enough. You'll notice that it updates these values to wherever you've dragged that character. So this is a nice thing to use when we're getting ready to reset our game. Every time somebody starts, we want everything to kind of jump back to where it was when we started the game. So we'll use all of these different blocks to set up the position initially. But the important thing is that each of these blocks has a different function. In this case, move 10 steps just moves Scratch forward in whatever direction he's facing by 10 steps. And then I can also point him in a specific direction or point him towards the mouse pointer. So in this case, my mouse pointer is facing this way, so he's going to point directly at the mouse pointer. Does that make sense so far? Thumbs up?
Yeah. Yeah, and Derek?
Yep.
Yeah, and I take it when we're eventually going to have more than one sprite in our in our window, and I take it that whichever one is highlighted down here below the what do you call this space, the white space up there?
The stage.
The stage, whatever sprites there are below, whichever one is highlighted is the one where we see the scripts. The scripts in the script window apply to the one that's highlighted.
Correct.
Right?
Correct. Yeah, the scripts will apply to that, and you'll see that, like you said, when we actually add in that next sprite, you'll see because the entire window will kind of change. Anything that we've done before will almost go away. It's still saved, but each sprite has its own individual script window.
Yeah.
All right. So to start, I'm going to reset everything to the way it was when we initially got here. So I'm going to, on this go to block, I'm going to set it to 0, 0, and then double click on it so that Scratch goes right into the middle of the stage. And then I'm going to double click on the point in 90 degrees direction so that combining these two, the 0, 0 and the point in direction blocks, essentially resets the stage so that Scratch is pointing to the right and then he's right in the middle of the stage. Okay, and so now we're going to write our first small block of code. And what that's going to do is it's just going to move Scratch 10 steps, then 10 steps again, then 10 steps again. Then it's going to point him in the other direction, and then move 10 steps, 10 steps, and 10 steps. So essentially, he moves to the right, turns around, moves to the left, and then comes back to the start point. Okay? Now, the way that you run a Scratch project is using these icons at the top of the stage on the right-hand side. There's a green flag that's essentially go. That would run our program, and then there's a stop button that stops our program from running. Okay? Now, in order to get these steps to kind of execute when we hit the green flag, we need an additional block, which is called an event block. So these first two categories are really the ones that we're going to use the most. So I'm going to click on events, and you'll notice that there's a block that says when green flag clicked. So I'm just going to drag that to the top of my steps here. And again, just like the recipe says, when I click the go flag, he's going to move 10 steps, move 10 steps, move 10 steps. He's going to point himself in the opposite direction and then move 10 steps, 30 steps total back, and then point himself back in the right direction. Okay. Now, don't get too excited because you'll notice something happen when we actually hit the green flag. So I'm going to hit it, and then we'll see how it goes. So I'm hitting the green flag. I'm kind of seeing a flash happen. So what's the problem here? Can anybody tell me what they think is the issue right now? I'm clicking the green flag, and yet nothing is happening.
Is it that your sprite is not on the stage down here below the stage? There's some little white thing. Does it need to be in there or something, or?
Nope. So this is the actual. So with the stage is technically considered just like any other sprite or any other object. So just like I can have a sprite doesn't necessarily have like a way that it looks, but we have different ways that you can make it look. So I could potentially click on the stage here and choose a different background. So in fact, let's do that for right now, just so it looks nice. So notice how that little icon changed, and I can select it.
Got it.
But Scratch he is selected. He is our sprite, and we've got a code block for when the flag is clicked, but it doesn't seem to be doing anything. Anybody want to venture a guess? So Fernando, I think he's got a guess. Go ahead and unmute yourself and give me your guess.
Ready? Can you hear me?
Yep, go for it.
Yeah, what about the stop at the end of the process? No?
So
we need to tell the old instruction to stop at the end?
not quite. Not quite. We can. We do have blocks that will allow us to stop the project, but we don't need that in order for it to follow the instructions. So here's a really, really important point, and I just did this specifically to address kind of what I said a few minutes ago. Scratch will only do exactly what you tell it to do, and unlike what we typically assume or unlike what we typically do when we're following instructions, we follow instructions in order, and we do them one step at a time. Okay. Scratch, on the other hand, because it's a computer, can do all of these steps instantaneously. They are happening. They're happening in the order that we've specified, but they're happening so fast that it looks like nothing's happening. And that's part of the reason why I set this up, so that it went back to exactly the spot that we started off from, so that it would look like nothing was happening. But if I remove some of these blocks and just tell it to move 10 steps, you'll notice that now it's doing all 30 steps all at the same time. And when I add these in, it's now doing those at the same time, and then I'm pointing it back. And now again, it looks like it's not moving at all. So it's doing all these steps. It's doing them in the order we're specifying. It's just doing them so quickly that we don't see the distinctions happen. We don't see each step happen individually. We only see kind of the general picture, the grand scheme of everything after it's been completed. Does that make sense to everybody?
Yep.
So imagine you're doing those steps, you're doing them in order, but you're doing them in a split second. So it's moving 30 steps forward, it's turning around, moving 30 steps back, and then turning around again to put us right back in the spot that we started off with.
Yeah.
We humans so quickly.
We humans tend not to realize how fast computers can do things.
Exactly. Exactly. And so it's really, really important that as you start working on your program, you'll run into these kinds of issues all the time. And it's just a matter of getting your brain into the process that despite what you think is supposed to happen, the computer is doing exactly what you're telling it to do. It's just, it might be doing it quicker than you assume, or it might be doing it in a different order that you assumed things might happen in. So it's really, really important to keep that in the back of your head.
Can I ask a question?
Yeah, absolutely.
So how do you know when you're programming something that is that fast and something that will look like normal?
So it's always going to function that
will
quickly.
It be the length of the program?
Say that again?
Will it be the length of the program, or how will you know that this is happening? And
it will happen every time, unless you tell it, and this is kind of the lead up to the next point, unless you tell Scratch to wait in between steps, or to specifically do two things at different times, it's going to do them instantly.
Okay.
Okay, and so
this could be this program could be 1,000 steps long, and it will still do it instantaneously.
Correct.
Well,
correct. Okay. As you get into complicated programs where there's like logic and branching, and you're using variables, it may slow down the program, but it's not going to slow it down enough to where it will function in like real time, or what you would expect to be in real time. So, and there's a couple tricks that we can use to kind of make this work the way that we want to. It's an important part of the process. It's important to get it to work the way that we want to. But it's just more important to know that it's doing exactly what you tell it to, and that again, if you see issues like this where you're running your program and it's not doing anything, especially, so it might be hard to see because it's going so fast, but can you guys see how the blocks over here on the right hand side are kind of getting highlighted in yellow as I click the green start button? Can you guys see that happening?
Yeah, not every time, but
yeah, and that's just because it's happening so fast. The block is starting and then ending right away. So that yellow block, or that yellow highlight, tells you what Scratch is running at any given time. So just to kind of put this in a little bit more of a process of what we want, or to put this closer to what we want in like a real-time game, our next set of blocks that we're going to jump into is the control blocks. And the only reason we're going to jump in here for now, most of them we're going to save until next week when we actually go into the logic of everything. but we have a block that allows you to wait a certain amount of time. So I'm going to insert a bunch of these wait blocks in between each of these steps, just so you can see a little bit better kind of the process that Scratch is running through, and you'll see what I'm referring to when we get that highlight. So,
and you're just dragging and dropping with your left button, right?
Yep. I'm just clicking the left button and dragging and dropping the blocks in there. Cool. So when we click the green flag, we're going to move 10 steps, wait a second, move 10 steps, wait a second. So all the instructions are still exactly the same. We're just waiting in between each step. And so now you should see something more closely resembling what we were expecting. Okay.
Yeah.
So that's our program. That's our very, very basic click the flag, move to the right, turn around, move to the left.
Is there a motion block that says go home, go to the center, go to the... Oh,
there's
there you
go home. Yeah, there's not go home, but you can specify coordinates. And actually, we're going to add that in just so that no matter what happens, we can drag Scratch somewhere else on the screen. When we hit the green flag, he's going to jump back to that.
Yeah, very good. Okay.
All right.
Can I ask another question?
Yep.
Is this all based on coordinates then?
Yes. Yeah, X and Y coordinates. And as I mentioned at the beginning, the stage, if you look in the bottom right-hand corner here, it will tell you the coordinates. So if I click and drag him, it will tell me the coordinates here. I can also specify coordinates as well.
So this assumes that the students are fairly knowledgeable about coordinates and the plane.
They don't have to know about the coordinates. They'll just have to kind of keep track. And most of the stuff that we're going to do isn't going to rely directly on the coordinates. They just need to know that right is positive, left is negative, up is positive, and down is negative.
Okay.
Yeah, there's not going to be any math involved with actually moving the character to those places. Scratch has blocks for all that stuff. They just need to know the positive and negative so that they can tell what direction they're moving in. Okay, so now that we've got a basic program and some recipes, there's obviously an issue with our program. It's not a huge issue, but it's kind of cosmetic, and that's that when we run it, Scratch flips upside down.
Yes.
And the reason for that is because we're pointing him in a direction, and just by virtue of the way that directions work, he's turning around 15 degrees at a time. He's rotating just like we might not expect him to, but that's exactly what we're telling him to do. Yeah. So another thing that we want to do just to make sure that we're not kind of messing up with that rotation is we also want to default him pointing in the 90-degree direction when we start, so that when our program starts, we reset him to the middle, we point him to the right, and then we run our program. But Scratch, for each object, has some properties that we can change for those objects. And we get to those properties by clicking on the sprite that we want to use, and then clicking this little letter I. So blue circle with a white letter I in the middle, and that's the info for a specific sprite. So as I click on that little letter I, I'm going to get information about this sprite. And the first thing I want to change about Scratch is his name. As we start getting a bunch of sprites into our project, what you're going to see is that the names might get confusing if you're just calling them Sprite 1, Sprite 2, Sprite 3, Sprite 4, especially when we get into projects or games where you have multiple sprites that look the same but have different functions or do different things or have different attributes. That gets really confusing. So you'll want to name them something that helps you kind of remember exactly what they do or what you're going to use them for. So in this case, I'm going to just name him Scratch the Cat. And then we can set the direction here if we want to. We're already setting it in our code, so I'm going to leave it the way it is. But here's the part that we're going to use to fix our issue, and that's the rotation style. So the default rotation style is a 360-degree circle. The next rotation style is just a left and right rotation, and that's shown by two arrows pointing to the left and pointing to the right. And so what this does is if I set that direction and then run my program, Scratch will still rotate in that direction, but he will only rotate in that direction either to the left or to the right. He won't go upside down. He won't go right side up. It's just a flip. So you'll notice he flips to the left, does that rotation, and then flips back to the right. Okay. This is important for objects that we know we don't need to rotate. There are some objects that we will want to rotate 360 degrees, but for things like characters in a game like this where he can only move left and right, really, we don't necessarily need him to be able to flip around or flip upside down or any of that stuff. Okay, and then the last two options are whether or not you can drag him. So we can drag him as the authors of this, but we can also allow players to drag that character around in the player if we want to. For our case, we don't want them to be able to do that because we're going to use our game logic to have them control the character. But you can set it so that they can drag it if they need to. And then the last one is show, whether or not we want that character to actually show up in the player. For right now, all of our sprites are going to be shown. In the very last training session, we'll more than likely talk about, depending on how far we get, we'll talk about some tricks that you can do by having sprites that aren't necessarily visible in the player. So does that make sense, how we fix that rotation? So
yes.
Just make sure your rotation, again, full 360 rotation, just left and right rotation, or the last one doesn't allow any rotation. So what you'll see if we play this is it'll do, it's technically called a point rotation, but point rotations don't do anything. They just keep the player locked to whatever direction they're in. So we're going to keep it as the left-right rotation just so Scratch flips back and forth. Okay, so now what we're going to do is we're going to actually create our first game. So I'm going to just grab this whole block of code, and you can delete blocks of code just by dragging them back into this middle section. So I'll do it one at a time, but you'll notice that it doesn't matter where I drag them, they just kind of disappear, or I can drag the entire block, and then that whole block disappears. Okay, so as you're working on stuff, you're probably going to want to mess around and play with a few different things, but this will at least get you to be able to empty your code blocks and get rid of them just by dragging them onto here. So I'll start by dragging Scratch onto the ground here, or as close to the ground as I can. And my direction or my coordinates have updated, so I'm going to replace my 0, 0 coordinates and get rid of them with my go-to block. So now whenever I start my game, no matter what happens, he's always going to end up back at that spot facing in that direction. Okay. And so we're going to add our very first, or I shouldn't say first, our second sprite. So our first custom sprite. And this is just going to be an object. What we're going to start off with is I'm going to make an object that Scratch can interact with, and we're going to decide kind of what he's going to do with that object. But for right now, I just want to add the object. So I'm kind of going to take a poll. I'm going to add a new sprite, and we have a couple different ways to add new sprites, and the same options apply for that background that we were talking about earlier. So I can load a background or a sprite from the Scratch library, which is just stuff that Scratch has already provided for us. I can draw a new sprite or a new background using this little paintbrush icon. And all that does is it gives me a canvas with some tools, really basic, like Microsoft Paint or some really basic Photoshop tools where we can create shapes and lines and things like that. We can load sprites from a file. So if we've already made sprite images in advance and we want to use those, we can load them from a file, and that just loads up a box to load up some files from your computer. Or we can create a sprite from a camera. So we're obviously using our webcams right now for this Hangout session, so I won't be able to use that to take pictures. But you can create pictures of yourself or characters or items. You can hold them up to your webcam take a picture of them, and then you can edit them and clean them up if you want to. So you can use your webcam to do either backgrounds or sprites as well. Now, we're just going to use the sprite library that Scratch gives because it's really easy to use that. And so I'm going to grab just an item, our first item that we can interact with. And let's do
donuts. Oh, never mind.
Somebody's hungry. Actually, I think I'm just going to do the cowbell because we need more cowbell in this project. Okay, so I've got a cowbell, and I'm going to drag it to where I want it to go. And again, just like with our Scratch item, and actually I'm going to delete this sprite. So I'm going to delete this sprite. I created a new sprite by painting, but we're not going to use that one. So I'm going to just right-click on it and delete. And so that way we only have our two sprites, our Scratch the Cat and our cowbell. And you'll notice that as I click on each one, our blocks change here in the middle and our code window changes. So this instructions that I had just for Scratch the Cat don't apply to that cowbell. So each sprite has its own set of instructions that happen as we move them. Okay. So what I'm going to do is I'm going to have Scratch move to the cowbell, and once he gets to the cowbell, I'm going to have the cowbell make some noise. So the way that we do that, the first thing we're going to start off with, we got our cowbell in the kind of basic area that we want it. So we're going to write our first instructions to just have Scratch the Cat move to the cowbell. So our block is going to look really similar to what it looked like before. I'm going to go into motion, move 10 steps forward. I'm going to wait 1 second, move him 10 steps forward, wait 10 seconds. And now what you'll notice is that we've kind of gone through and we're just going to be doing the same thing over and over and over again until Scratch gets to the cowbell. He moves 10 steps, he waits a second. He moves 10 steps, waits a second. This can get kind of repetitive and your code blocks can kind of get pretty long. So under the control window, we actually have a block specifically for repeating things over and over and over again. And I'm just going to grab that block, and what you'll notice is that as I kind of move this stuff into place, this block resizes itself depending on where I drag it to. Okay, so I just want to repeat 2 of those steps. I just want to repeat the move and the wait steps. And I'm actually going to junk the first 2. So now he's going to do this set of steps 10 times. He's going to move to the right, wait a second, move to the right, wait a second, move. He's going to do that 10 times. So now if I start my program, and we can count each step as he does this because we've put that wait in there. And that's how far he's gotten. So now I'm going to bump this up to 25. Okay, so you'll notice it's kind of slow, taking a little bit of time. We're moving along kind of slowly. It's eventually going to get to where we want it to go, but it's not the best way to do this.
I take it you can make the wait a fraction of a second if you want.
Yeah, you can. I believe you can make it as little as 0.25. Actually, I think 0.1. Anything more than double decimals will get rounded.
Okay.
So 0.01 is probably the fastest.
So when Scratch moves, he doesn't really look like he's moving, right? Like in the cartoons.
Right, because he's not animated, and we'll get to that a little bit later. But he is moving. He's just not animated.
All right.
Okay, so we have one way to move Scratch, but obviously we'd have to mess with how many times he actually does this little repeat. Maybe we would mess with how far he moves each step, or like was mentioned, the delay to make it go a little bit faster. And eventually we might find the right combination that gets him right to the cowbell. Okay, but there's an easier way to do this. I'm going to grab my repeat block and I'm going to junk it. And I'm going to go back into my motion.
Oh, hey, how did you do that? How did you junk it? Because it seemed to go faster. Oh.
Let me just put that back in really quick. So all I did was I grabbed the block that started, so in this case, the whole repeat block, and I just dragged it right back into that middle section.
Got it. Okay, cool.
You can also right-click on a block in delete. The only thing I would caution against using that is that if blocks are connected, like a for loop, for example, or like a repeat block like we just had, it'll delete all of them. And sometimes that's not what you want. Sometimes you just want to delete one individual block. So I just think it's a lot more precise or a lot more intentional to grab the actual blocks that you want to delete and drag them in the middle.
Cool. Okay.
All right, so another way that we can do kind of that motion that we had is I'm going to reset this. So since I have my reset blocks here, just running my program puts them back into the beginning. And I have a couple other ways that I can move Scratch. I can either just put him right where I want him. So again, I can drag, plop him there, and my go-to blocks have updated. So now if I run my program, same thing happens. It does that all immediately. So I can maybe put my weight block in there. But what happens is it happens instantaneously. It's almost like he teleports to that area. Okay, so if you've been looking through some of those motion blocks, you'll probably have found that there is a block that says glide. And we're only going to use this glide block for the first couple parts of our training, but it's a really nice solution to kind of the problem that we're experiencing, or the item that we want. So what the glide block does is it tells Scratch to move to a specific set of coordinates within a certain amount of time. So essentially this glide function is move to X 173, Y negative 109 in 1 second or 3 seconds. So over the span of 3 seconds, he's going to slowly move from wherever he currently is to that final section. Okay.
Now I noticed that he still seems to move in increments. He doesn't really seem to be gliding. So I take it Scratch has its own way of dividing up that 3 seconds.
It should be smooth. I think the reason that it's not smooth is because the animation on Hangouts is just getting a little choppy.
Got it. It's a bandwidth issue then.
Probably.
Yeah. Okay.
And actually, the other thing that it might be too is our coordinates. So if you look at our X and Y values, the Y values are not exactly the same. So technically he's moving diagonally very slightly, and that might also cause some of that choppiness. But for the most part, there's a bunch of problems with this glide block, which is part of the reason that we're not going to use it as we get into our actual code later on. But for right now, it kind of does what we want it to do.
Yeah.
So we'll leave that the way it is. So each time I run my program, he resets to the beginning and glides to that area. Okay, so now we just need to set up our actions for the actual cowbell. So the cowbell, we're going to want it to play a sound when Scratch gets to it, whether it's, hopefully they have a cowbell sound, but if not, we'll just make it play some kind of music or something. So again, we're going to start with our event block and say when the flag is clicked, we want something to happen. Okay, and if we look through some of our other blocks, we're getting close to the end of our session, so this is going to be part of your homework. We're going to get some of this done, but we're going to get some homework going as well. So when we start the flag clicked, okay, we can go to the sound. Oh, there is a cowbell sound. All right. We're going to start with the sound, and we're just going to say, when clicked, play cowbell. Now, obviously, that's not going to be correct because when we start our project, it plays that sound. Can you guys hear that sound, by the way?
I cannot.
Okay. I didn't think Hangouts would be able to play the sound, but it is playing a cowbell, kind of like a dunk sound. But that happens as soon as we start our project. Okay. So we got a couple ways that we can kind of check whether or not Scratch is there yet. Okay. One way is we can make the sound happen when Scratch finishes his first glide. So the glide block, as I mentioned, the glide block is kind of like a go to this area in this certain amount of time, and it won't continue to the next step until that time frame has passed. So in this case, this is one of the blocks that does actually wait before moving on to the next step, unlike those go to and move blocks that we used before. So I could technically go in here and have him play the sound once he's done playing his steps, and that would work. Okay, so under the Sounds tab, I can load a sound from the library, which was cowbell. Where's cowbell? Large cowbell. Large cowbell. I'm going to pick this sound. And now I have the option in this drop down to use a large cowbell sound. So when I start my program, Scratch gets to it, and he'll play the cowbell sound. Okay. The other way that I can do it is I can go into some of my other blocks, and this is kind of where you'll be able to experiment with this for your homework. But we have some logic, and since our next week's topic is going to start with some of this logic, I'm going to jump into the control section and pick a block that says, if something, then do something. And all I'm saying here is that if something is happening, do this, or repeat until this. So we got a couple different blocks of logic that we can use. Okay. So I'm going to say, if something is happening, then play the cowbell. And in this case, what that something is if Scratch is touching, if Scratch the cat is touching the cowbell, then play that sound. Does that make sense?
Yeah.
Okay. And we have a really easy way to check for that. And Scratch has some other blocks called sensing blocks. And sensing blocks just do various, they're various predefined code segments that, yeah, we could technically write ourselves to find out if Scratch is at the same X and Y coordinates as the cowbell. But in this case, Scratch has blocks that are preset. So if our cowbell is touching Scratch the cat, which I just picked from the drop down, then play that sound. If one color is touching another color, if the distance to the mouse or Scratch the cat is within a certain space, are we holding down a key? Are we pressing the mouse button? So I could even make this so that if we press the space bar, every single time I press space bar, it plays the cowbell sound. Okay. In this case, I just want to check if the cowbell is touching Scratch the cat, then play the sound. Does that make sense? All right, I see some nods, so that's good. All right, but we're going to find out that there's an issue with this. And just like we found out from the beginning, Scratch only does exactly what you tell it to. And so right now, if I'm playing this, you guys can't hear it, but it's not actually playing the cowbell sound. I keep pushing the button, and it's not playing anything. It's not playing anything beforehand. It's not playing anything when he gets there. And the reason for that is because, as I mentioned, Scratch only does exactly what we tell it to. And in this case, what we've told it to do is when we hit the go button, immediately check if Scratch the cat is touching our cowbell. And if he is, play the sound. Well, when I hit the go button, he's not, because we're resetting him to the beginning of the stage every single time. So at the time that that command is being issued, he's not actually touching the cowbell. Okay. So what we need to do is we need to tell Scratch to check if the cowbell is touching Scratch the cat over and over and over again repeatedly until he finally does. Okay, and there's a couple different ways that we can do it. I'm going to do an easy way first, It's not the best way to do it. So I'm going to show you guys how to do it one way. And then your homework for next week before we start is to try and figure out a way to do it that doesn't have the problems that the one that we're doing shows. So I'll show you guys in a second what the issue is. And luckily you won't be able to hear it, but I will. So one of the blocks that we have under control is a loop block called forever. And this block just does whatever's inside that block, it will literally do that forever. It will continue to check that until whatever we tell it to do happens. Okay, so when we click the flag, this forever block starts, and what happens inside here is just going to go over and over and over again. So it's almost going to be like the annoying kids in the back seat of the car. Are we there yet? 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 That's basically what it's going to be doing. Are we touching it? 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 And it's just going to keep doing that over and over and over until Scratch the Cat actually touches that cowbell. Okay. Now, if you guys aren't following along with this, you're not going to appreciate the annoyance of this. But because we've told Scratch to stop at the cowbell and this thing runs forever, as soon as Scratch gets to the cowbell, that cowbell sound plays over and over and over and over and over and over again. So when I hit this flag, I'm going to be annoyed by cowbell sounds playing repeatedly. So nothing yet. And then cowbell just goes over and over and over and over again. Okay. So that's obviously a big problem. We basically got to the gist of what we wanted, which is when Scratch gets to the cowbell, that plays indefinitely. But we need to figure out a way to get this to happen and only happen once. So we want to do the check forever, but we only want to do it once. Okay. So that's going to be your homework, is to figure out how to get Scratch the Cat, or how to get the cowbell to only play once Scratch the Cat touches it. Okay. I'm going to go over a couple more things before I let you guys go. Bob, we're scheduled for an hour, right?
We are, yes.
Okay. I just want to make sure I'm sensitive of everybody's time if anybody has to leave. What time did we start?
We start about 6 after 10.
Okay, so I'll go for another 10 minutes, and we'll cover some different blocks here. But I want you guys to kind of figure out some of the different ways, because there's more than one answer. That's another big thing to always keep in mind. Besides the fact that the computer does exactly what you tell it to, there's always more than one way to, figuratively, of course, skin or scratch a cat. So no matter what you do, there's always another way to do it. It might not be better. It could be better. Depends on what better actually means. But there's always going to be more than one way to do something. Okay, so I'm going to disconnect this for a second and just talk about some of the other blocks that might help you figure out how to do this. So we've talked about some of these other control blocks, which is the wait block, which basically tells it to wait before it continues. That might help the problem a little bit. If I push this back in here. So now I get the cowbell over and over and over again, but it waits 1 second in between, which is a little bit more manageable. I'm just getting a dink, 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 instead of being bombarded by some of those. But we can also look at some of these other blocks. And again, I'm not going to show you the answer right now, but I'll just explain what some of these blocks do, and then you guys hopefully can try and piece together what they do just by playing around with it. I don't expect everybody to get the homework done, especially if this is your first go around with coding, but hopefully you can play around with it a little bit and maybe stumble upon the answer. So our repeat 10 block we already talked about. That just repeats whatever code is inside of it that number of times. The forever block, like we talked about here, repeats over and over and over and over again. Our if block checks if something is happening And if it is, then it does something. Otherwise, it does nothing. So it just kind of moves on to the next step if nothing is happening. Our next block is what's called an if-then-else block. And that just checks, just like the if block before it, it checks if something is happening. If it is, then it does something. If it's not, it does something else. Okay. We have a wait until block, which holds the program until something happens. Okay. Now, what's important to note about this block is that it's specific to each sprite. So all it does is it holds off on that sprite. So in this case, we could wait until Scratch the Cat is touching, oops, I deleted that instead. We could wait until Scratch the Cat is touching that block, but it only happens for whatever sprite is highlighted. So Scratch the Cat will continue to do whatever he's programmed to do, but the cowbell will wait until something happens. Okay. We've got a repeat until block. So this is kind of like the forever block, except that it continues to do something over and over and over until something happens, which could be Scratch touching the cowbell or one of our other sensing blocks. We click the mouse, we click the space bar, we click something. We've got a block that stops everything. So this one is different from the wait block in that it can stop the entire Scratch program. It can stop just the script that it's part of, so just the group of blocks that it's a part of, or it can stop all the other blocks on this sprite. And so I'm just going to clarify that a little bit. So I'll move this back into here. I can have as many of these when flag clicked blocks as I want to. Or I can use some of these other event blocks if I want to. We're going to talk about events a little bit in the third session, and actually maybe even a little bit in the second session. But you can have as many of these event blocks as you want. So I could potentially have this cowbell moving around back and forth if I want to as well. And then have that repeat forever. So now if I start my program, the cowbell will move back and forth over and over and over again. Okay, and then I could still have something else happening that does the same thing, but instead of moving it 10 steps, maybe we'll make it move up and down. So the same way that we're moving 10 steps to the right, positive, to the left, negative, positive is up, negative is down. I shouldn't have deleted my old one. And again, this isn't the only way to do this. There are a couple different ways to do it, so you can play around at your leisure. But now you'll notice that the cowbell is moving up and down and left and right. Oh, oops. Negative. Again, it does exactly what you tell it to do. Actually, let me... Does that make sense? So you'll notice now that these three blocks are highlighted in yellow. That means that they're running, like we talked about before. And the reason they're running is because we have these forever blocks. So Scratch is just doing this over and over and over and over and over into infinity.
And Derek, I guess I've been switching back and forth to the YouTube window, so I may have missed something. How is it that you have Scratch the Cat moving across the screen? Because I don't see a block for that. Did you do something to make him do that?
Yeah, so if you go back, so one of the things you'll have to remember is that each sprite has its own set of code.
Okay.
So right now I have the cowbell highlighted, so we're only seeing the code for the cowbell.
Oh.
If I click on scratch the cat, though, we still
there
see
he
that
is.
block that we created right at the beginning.
Okay. Okay. I lost track of the context. Okay. Fair enough. Thank you.
Yeah. So just keep in mind that you'll be switching back and forth. And actually, one other thing that I do want to mention too is you can also have code specifically for the stage. And
yes,
as we get into games, we'll talk about this a little bit more. But the stage is almost like the level, and you may also want logic for when somebody beats a level, change the background, or when somebody does loses, put a game over display on the screen or something like that. So each object will have its own set of instructions that it does. And again, it does it independently. So whereas our scratch instructions, start, he goes to that spot, he points in that direction, and then over the course of 3 seconds, he moves and then stops. You'll notice that once he gets to that spot, it de-highlights. It's no longer highlighted in yellow. And that's because that code is done. It's no longer doing anything else. But on our cowbell, because of those forever blocks, that code is running over and over and over and over and over and over and over again.
Yeah. Okay.
So it's just something to keep in mind. As I said, when we get into games, we'll talk about some best practices, and when we get near the end, we'll talk about some best practices. But one of the things that you want to avoid whenever possible is making something that goes on forever that you only use once.
Yeah.
And that's just because you're using resources, you're using, the computer, you're using the processor and everything to just kind of keep going over and over and over and over again. So you'll just want to kind of be cognizant of that and be aware of it. All right, so we have a couple minutes left, I think, just a minute or two. If anybody has any questions on what we covered today, that's the basics of the Scratch interface. So like I said, your homework is to go in and see if you can set up the game so that Scratch moves from left to right, and when he hits the cowbell, it plays that sound once, or if you want to specify a certain number of times, 2 or 3 times, and then the game is over. You're more than welcome to do that. We'll talk about that, and we'll kind of go over that stuff next week in the next session.
And so Derek, I don't want to cut anybody else off if you guys have questions. But a question I have is just, can you just remind us of what the curriculum is for next week?
Yeah, give me just a sec. So next week we're going to talk about logic and variables, which we've done a little bit of logic here with our if-then block, but we're going to talk about how to actually make decisions and how to do things based on the input of the person actually playing the game or using our project. Okay. So there's a couple different ways that we can take input from people. Really what next week is all about the interactivity. We're going to make our project interactive so that you'll start to kind of see the basics of a game actually forming.
Cool. Very cool. Okay.
All right. So any questions?
And everybody, this session that we just went through today will be available on YouTube, and I'll put a link to it in an email and on the website within the next day or so you can run through it again if you need to pick up on something you missed or just want to get ultra clear on what Derek's telling us. So.
Yeah, and I just want to be really, really encouraging of playing around with this as much as possible. If you get a chance to play around with Scratch, because there's so much that you can do, and different concepts, especially when it comes to programming and the logic that we get into next week. It's not going to be as important as what we covered today, because today is kind of more of that just step 1, step 2, step 3 stuff. But when we get into the logic, you're going to discover that there's concepts that don't make sense until you try them out, and you might do something a specific way that helps it click for you. I can't emphasize enough, play around with it whenever possible. Try different variations of ways to do the things that you're trying to do and the things that you're trying to accomplish. Like I said, there's no wrong way to do something. There's only a million different ways to do the right thing. So
yeah. Great. Okay. Well,
any other questions? I think everybody's good.
Great. Thanks, Derek. Great job. I really appreciate it. And, we'll see you at 10 a.m. next Saturday.
All right. Sounds good, everyone. Thank you for joining, and we'll see you next week.
Thank you, Derek.
Thanks.
Take care, guys. Bye-bye.
Thank you, guys.